In this section of notes, we're going to learn the converse. That's the title. That's what it says. We're going to learn the converse of the Pythagorean theorem. And, well, first, the Pythagorean theorem says that if we have a right triangle, then a squared plus b squared equals c squared. The two legs, when you square them and add them, it's the same thing as the hypotenuse squared. Well, the converse says, let me write it down, yeah? Okay. So here's what it says. If that's awful. If a squared plus b squared equals c squared works, so if you can get numbers and square them and add them up and it's the same thing as the hypotenuse or the longest side squared, then you automatically know that whatever triangle you are working on is a right triangle. So you don't need to know it's the right triangle first. You can just test it out, test this out, and if this works, it's a right triangle. So let's look at the first example. It says determine whether the given figure is a right, and that means triangle. So determine whether this is a right triangle. Really, all I'm going to do is use that. And the only requirement is that my C value has to be the largest one. So maybe I'll write that down. So my C value must be the largest in the triangle. So 78 is bigger than 72 and bigger than 30. So 78 has to be my C value. Now all I'm going to do is check what is 30 squared plus 72 squared. Is that equal to 78 squared? And we'll see. I'm just going to plug things into a calculator. This is 900 plus 72 squared is 5084, and then over here 78 squared is 6084. Now if we add these two together, what do we get? I'm just going to do it in a calculator. Yes, that's 6084. So those two are equal. That means this works. This works. So it's definitely a right triangle. So determine whether the figure is a right triangle. Yes, it's a right triangle. And that is all you do for this one. Some things to keep in mind for this example, for this problem. Maybe you should write this down. I don't want to write down too much. So I guess I already wrote it down. The C value has to be the largest out of the three sides of the triangle. The C value has to be the largest, so you have that written down already. And also, all you're doing is checking to make sure that that works. Okay, so pick out your C value, square the other two, make sure that this is the same as that. If it's not, then it's not a right triangle. In fact, let's do an example where that happens. Actually, before we get to the next example, I want you to remember, completely recall this. For a triangle, the sum, which means you're adding them together, the sum of any two sides, so pick any two, add them together, that has to be greater than the third side. If it's not, then you can't make a triangle. Alright, so that was the example where, like, if you have this side and this side plus this side wasn't big enough, then when you swung this down, it would never touch the other side. So it doesn't, like, there's so much space in the middle, you can't make a triangle. They're too small. So this side plus this side has to be longer, has to be bigger than that side. That's what that example was. So just remember that that has to happen. And then now we can do this example. So in this example, it says, can you make a triangle? Can you make a triangle, man? If so, is it right, acute, or obtuse? So they give us three values here. And first we got to use that and decide whether we can make a triangle or not. So if we take any two sides, I'm just going to take those two, add them together. That's what, 59? That's definitely bigger than that. Okay, that works. 50 plus 49 is definitely bigger than 10. 10 plus 50 is definitely bigger than 49. So yes, you can make a triangle. You can always just check that in your head. So remember, just check that, and you can definitely make a triangle because you can add them together, and it's bigger than the third side. So yes, you can make a triangle. Now, is it right, acute, or obtuse? We can use the converse of the Pythagorean theorem. Does Well, this has to be C, right? It has to be the C value because it's the largest out of the three. And so then I can just check. Okay, is 10 squared plus 49 squared. What is that? That's 100. That's 2,401. If I add that together, that's 2,501. And then I just got to check my C squared value. Well, that's 2,500. Oh, look, they're not the same. They are not equal. That's the not equal symbol. So it cannot be a right triangle. So it's not right. That ain't right, man. M and the D. That ain't right. That ain't right. Yeah, you're right. No, I said that ain't right. No, I mean you're right. Like you're correct. Yeah, but oh, I get it. So this one's not a right triangle, and we actually have a theorem, or we're going to have a theorem. I haven't told you yet. That tells us whether it's acute or obtuse. If the C value squared is bigger, so like if the hypotenuse in quotations, if that's bigger, if this is bigger, then we have an obtuse angle there. If it's smaller, then we have an acute angle there. Bigger or smaller than what? What am I talking about? If this is bigger than this, so if the C squared value is bigger than A squared plus B squared, you have obtuse. If it's smaller, you have acute. So in this case, it's acute. And I'm going to write down everything that I just said on the next page. So this is acute. Oh, isn't it so cute? No, it's acute. Oh, it's just so cute. No, acute. That's what I said. Get out, leave. Okay, before I write down this theorem, I'm actually going to kind of write down like a flow map for this, the way you think about this. But usually what we do is we figure out those, we calculate those, and we compare it with this. So here's the question that you got to ask yourself. Do you feel lucky? Well, oh no, do I feel lucky? Well, do ya? So there's one question. I don't know how to do his voice. I'm gonna not do that then. Okay? I'm not gonna do it, alright? Is this bigger than that? So that's what I'm gonna say. So is C squared, is that number bigger than A squared plus B squared? So that's your first question. And then that's a yes or no question. So maybe your answer is no, maybe your answer is yes. If your answer is yes, then automatically it's an obtuse triangle. Okay, so that's the yes part, and that pretty much flows from if the longest side is bigger than those two added together, then I'm sorry, not if it's bigger, because it can't be, otherwise it's not a triangle. If the square of this, if C squared is bigger than A squared plus B squared, then that will be an obtuse angle. You know what? I'm gonna make these different colors so that because they're sub boxes. Now there's a different situation for the no case. So is C squared bigger? No. Okay. Is it the same? Okay. So maybe you can't really see that arrow that much, but it's going downwards. That's a downwards arrow. Yeah, that's good. Is C squared the same? That's yes or no. So yeah, is it the same? Yes or no? If it's yes, then you have a right triangle. We already decided that. If it's not the same, then you have an acute triangle, because that just means it's smaller. Yeah, so that's one way to think about this. On the next page, I'm going to do a simplified version, because really, if it's bigger, you have obtuse. If it's smaller, you have acute. And if it's the same, then it's a right triangle. So I'll write that down. But this is a good way to explain it, I feel like. But maybe it's not. I don't know. And there you have it, my friends. In other words, if C squared is bigger, it's obtuse. If it's smaller, it's acute. And if it's equal, then it's a right triangle. Very good. We are done.